everybody who is watching this video. I would like to welcome you. My name is OLENJOLAIM. I would like to welcome you into our online school that's called TANZANIA Online Advanced Secondary Schools. And we have our YouTube channels, official YouTube channel that's called TANZANIA Online A-Level Secondary School, in square bracket OLENJOLAIM, where that we are uploading many videos a day. I told you that open that window. Okay. So then, another thing that I'm from United Republic of Tanzania. I'm a Tanzanian, and my main focus in these programs is to use the syllabus of United Republic of Tanzania. And we have three departments. Departments of Advanced Physics, where we teach two subjects, Advanced Physics from 5 and Advanced Physics from 6. And also you have the Departments of Chemistry, Advanced Chemistry from 5, Advanced Chemistry from 6. And also you have the Departments of Advanced Mathematics, where we teach Advanced Mathematics from 5, Advanced Mathematics from 6, Basic Applied Mathematics from 5, and Basic Applied Mathematics from 6. So today we are in Advanced Departments of Advanced Physics. The subject is Advanced Physics for the Form 5. The main topic is electrostatic. The subtopic or the topic that you are learning is the general introduction. It's electrostatic force. That's the topic that you are learning. So I think that we say that the force of attractions or repulsions between the charges. This contains specifically for the Form 5 or class 13. And then we are in lecture or session 7, which is problem solving in fundamental Coulomb's and superposition principle, part 2. So in session 6, I told you part 1, so this is part 2. Well, just to do, actually that, okay, because, you know, many students are waiting, first of all, quick review of session what? Session 6. Well, so session 6, it has session, we have session 6A and session 6B. Session 6B. So we have 3 sessions, 2 sessions there, subsessions. Well, so here we solved it. Okay, we solved it 4 examples, 3, and one was one of example. The first example was testing about the means that you can means that is example 5. You can the force of attraction. There is 2 situations of the charge of which the 2 point charge have been placed in. The force of attractions in the first case was 16 Newton, but we have the quantity of charge Q and Q. The second case, we find that the quantity of charge for one atom, for one charge, is increased by 5.6 microcoulomb, and the other one is still there, but the distance also it has been increased. Here it was 0.09, and here now it is 0.12. So we dealt with that problems, and finally we found it. Again, example 6. Example 6. Now we began to teach about we have quantity of charges, and then about the resultant force. And example 7 was the homework. We gave you 4 quantity of charge. So we gave you Q1, we give you Q2, we gave you Q3, which is X, and we gave you possibly Q4. So we asked you to find the resultant force along the QX. So the resultant force, we say that is both magnitude and direction and direction. So today, we want to take you on to the next level. So if you have found that session 6 was challenging for those problems that you have solved, my dear students, I would like to tell you that that was still a foundation. So let us go in today's sessions, and we'll see some of the things that you have never expected in your life. Don't get confused if you go to your local classes or meet at your school sessions, and then your teacher will teach you about electrostatic, and then at the end, until the end, he or she will never teach you about these problems. Because these problems really, they need a teacher who is struggling a lot, who's spending much time on reading, and who is ready to learn new things. That's all. So I'm still waiting the corrections. I mean that the solution for the homework 6, I left the questions, so I'm still waiting the comment sections. Once I see there, if I see that the demand of doing the corrections, then I'll do the corrections in one of the sessions, right? So today, allow me to take you into example 09, for example 9. The figure below, so we have the figure. The figure below shows the charge, hey, close the windows and doors, show the charge, the outer one, okay, show the charge, or the charges in vacuum, okay, in vacuum. Find the resultant force. So listen carefully this example 9, okay, listen carefully this example 9, so that it may help you to know how you can solve example 6, which I gave you. Find the resultant force at T, point charge means at X. So you'll be given this figure, okay? So there you'll be given 3 point charge which are in triangle. In that example, or in the previous homework, I gave you 4 charges which are still on the straight line. Today we want to advance your understanding. This is Q3 is equal to 5 microcoulomb. This is Q2. This is still what? Is equal to 2 microcoulomb. Again, still have Q1. This is equal to what? Is equal to 4 microcoulomb. Okay, this is 2 centimeter, distance between them, and this also it is 2 centimeter. So it is collateral triangle. Possibly that I've made a mistake on sketching it, but this is collateral triangle. And here, it's a point where we have X. So this is point A, this is point B, this is point C, this is point D. So this 2 centimeter is a distance from Q1 to Q2. Welcome to enjoy the beauty of physics. I'm teaching you the concept that called the electrostatic force, electrostatic force between the 2 point charge. And you have to get prepared to enjoy the beauty of it. I say open the window, need fresh air. Solution. So this is the problem. Maybe even label the figure something. Maybe figure, don't remember that. Maybe figure 4, if I'm not mistaken. Select that, I didn't count. So the figure below shows the charges in vacuum. So all of these charges are in vacuum. Find the resultant force at X. Where is the X? This one. Find the resultant force at 30 at X. The distance between Q2 and Q1 is 2 centimeter. Q3 and Q2 is 2 centimeter. Q2 and Q1 is 2 centimeter. And this is collateral triangle. So you might think about resolving and having mass and whatever. That's another complication. But simply that you know that the angle between these angles are equal because it's collateral triangle. Right? So you have to follow steps. You can have the data given, but for me, I don't waste my time on doing that. The first step, you have to recall what? You have to recall the Coulomb's. Coulomb's are mathematical formula. Force of attraction is equal to proportionality constant K. Then you have Q1, Q2, this is the gamma, R square. So the mediums is free mediums, so we know that we have the permitted of the free space. Well, so we go. So after recalling that one, we go for the second stage. The second stage, we want to see the force of repulsion or attraction experienced by charge at the X due to Q2 Q1 and Q3. Right? Okay, so to do that, we say that first of all, we don't have any point of charge there at that point C. So we say that first of all, we have to say that let the quantity of charge, okay, the quantity of charge at point what? At point C or X to be 1 microcoulomb. If these Q1, Q2, Q1, Q2, Q3 are in Coulomb, you should also let you 1 Coulomb. Right? That's the principle. So afterward, so that's the second step. You can go for the third step. The third step, say that now let us find the force of, because this is positive, so you have let it positive what? 1 microcoulomb. So positive and positive. Because I said if the sign is not written, it means it's positive. So this X will be pushed by Q1. So instead of find Q1, Qx due to what? Q1. Find the repulsion force between Qx and Q1. So to find it, you say that in Q1, this is equal to what? 9 exponent 9. Let's have Q1. What is Q1? Q1 is 4 microfarad, means it's from -6. Then Q at X, it's 1 exponent -6 divided by distance between Q at X and Q1 is 1 centimeter because it's the bisecting into equal parts. So the distance from here to here, it is 1 centimeter. And also the distance from here to here is 1 centimeter. So the distance there is 1 centimeter. We have to express it in meter. Don't forget that. Then we square. So force acting on X is due to Q1. You have to use your scientific calculator when doing such computation. The answer is 360 Newton. 360 Newton. And these 360 Newtons, where the direction is. So you have Q1, we have Q, or we have X. So this one will be pushed towards sorting. So this you say that it is towards what? Towards charging at X. You have to be careful. The symbol for the charge is capital Q or small letter q. Some of the students, they write this, but it's not a quantity of charge. This is a symbol. This is another Greek letter which we call star. Some students, I know that in writing the quantity of charge, they write this one. This is theta, not the q, not the quantity of charge. So once you write this way and this way for the quantity of charge, you are wrong. Some of your students, they write like this way. That's not a quantity of charge. This is something else. So be careful on writing the notation. As I said, it might cost you, and then you'll get shocked that even this is small mistake. Yes. So then here we are. So we are done with that one. We want again to go for the first step. We say that we have to compute. Okay, we have to compute force acting on charge X due to what? Due to Q2. Where's Q2? Which one? So you have a force of repulsion there. So from Coulomb's mathematical equation, F of Q2 is equal to what? It's equal to 9 exponent 9, and then Q1 is 1, so -6, and this one is what? There it is 2 exponent -6. I wonder that students I have in this room are not writing. This is what is square. So if you do that computation, force at Xe due to Q2 is equal to what? So use your scientific calculator and then find it. One eighty Newton. This is also the partial. So this Q will push this one, push it away. So say that again, even this one is towards 40 X. But the force system, you go for the fifth system. The fifth system, we say that compute the force of attractions act on the quantum charge at X with what? With Q3, due to Q3. Be careful there. So let us find terms of magnitude. O should involve M because okay. So it is 9 exponent 9. Q1 is 1 exponent negative 6. Q2 is equal to what? Is equal to 5. We are looking for its magnitude first. Distance between this point and this point is equal to what? Yeah? Distance between this opposite of this angle is equal to what? Is equal to 2 square minus what? Minus 1 square. So 2, we say that 2 exponent negative 2 square minus means this one square minus this one. So you have 1 exponent negative 2 square. Okay? So we leave the problem in the blackboard, so you might see that how are we going to tackle it. And do your computation, excuse me, get 150.356. 150, do your computation there clear, but remember that. It's in the best way. Yeah, okay, because we need the square root solution. We need the square root of this, but also here we have r square, so we square. So the square root cancels with the square. So we just need this one. When we are looking for this side, listen, side AC square will be equal to side what? AB square minus what? Minus BC square. Right? So AC square is what we call TR. AC square, AC square, AC square, AC square. That's what we call TR. Distance between Q3 and Q at X. Right? So that's why that this computation is right. So the response 150.356 Newton. So it is positive, that is negative. So this also is toward X. But you have to understand, this is only vertical components of force. We don't have horizontal component there. So you have found those individual components. Here we are right now. We go for the sixth step. For the sixth step, if we analyze the problems, we have two horizontal components first, and they have one vertical component first. Remember that this charge is perpendicular to the QX. If this charge could be here, then we have another story. Right? If charge could be somewhere here, we have another story. Okay. So because this charge is perpendicular, so that's why that we say even its computations will be simple. Right? Are we together or should I repeat? Let me repeat. I say QX will be pushed by these charges Q1, Q2, Q3. Right? How? Q1 will charge the charge at QX, it means a repair, the certain magnitude. Horizontal, that is pure horizontal. Vertical here it is 0. Right? And this one will be pushed, just like this. Then you have Q2 also, it will push this QX. Right? It will push it out to QX. So then again, that this side you have also what? This side also you have what? Force of repulsion. And because of force of repulsion, we have two horizontal components. But this Q3 and Q of X, they are at perpendicular. Right? They are perpendicular. So that's why that you say that we should not involve too much of what you used to have in mechanics and so forth. Right? Okay. So the sixth step, we say that let us compute the resultant force. Right? The resultant force, say resultant force, the resultant horizontal force, the horizontal resultant force, or the horizontal, let us compute the horizontal resultant force. So if we check first of all, in order to know the resultant horizontal components, we should know also the force, the direction. Okay? So this is Q1. This is QX. This is Q2. Okay. What does Q1 do to QX? Pushes. What does Q2 do for QX? Pushes. So they are opposite direction. So which one is going to push it? The other one more. We don't know yet until we do the computation. So resultant force for this case now from this diagram, we say that this will be force on Q3 on QX. Force on X due to what? Q what? Due to, so which is larger? Due to Q2 or due to Q3? No, due to Q2 or due to Q1? What do you get for Q1? Yeah? I'm asking, what did you get it for Q1?
360.
360. And what do you get for Q2? 180, right? Huh? So Q2, 180. Q1, 180. 46. So it means you take your force on X due to Q1 minus force on X due to Q3. Due to Q2. Okay. Right? Are we together? Because this is stronger than this one. However, that you have to be careful, because sometimes that some of the teachers will teach you that we have to focus on this, respect of this. So you can find that sometimes that in explanation that these arrows will change. Be careful on the way of explaining. The issue is you have to challenge them. Why? So force along X will be what? The 60 Newton minus 180 Newton. Answer is equal to what? 180, isn't it? Yeah? Is equal to 180 Newton. Toward what? Toward right. Or towards what? Towards Q2. Right? That's horizontal component. It comes from vertical component. What point charge does give us the vertical component? It's only Q3. These force on X due to Q3 perpendicular or not? This is perpendicular, right? So because it's perpendicular, we say that the 7th step we say that the sigma, or we say that this is not important. We say that compute summations of vertical component, because we want to look for the resultant. So we say that because the problem that we have, the resultant is what? Okay, so for resultant force in vertical components is only due to Q3. So this is equal to force on X due to Q3, and this is 150.365, I'm not mistaken, Newton. Right? So then, my students are not even touching calculator, they just agree. Then, what do you say? We say that you find. So we have this resultant here, okay? So we say that this is the 8th step. Excuse me. So the 8th step is that compute the resultant force. Right? Of the resultant force. Taught in the previous session. The two previous sessions, right? So we say that this resultant force is equal to square root summation of f of x squared. So this is f of y. Right? So it's a resultant force for this case. And sum of f of x is equal to what? 180. And then the sum of y is what? 150. The answer is 7. So give me the resultant force. What do you get? 234.54 Newton. 234. 234. 54.
Yeah.
And what? Newton. What where? Huh? Don't know. Careful. Direction. Direction. So direction say that in case you are theta, tan inverse right? So you have the vertical components of our horizontal components. Sometimes if the sides are not given in the table, this relation also is giving you the direction. So add this formula in your mind. Okay, so he said that, excuse me. So he said that this one, we say that an inverse of what? Of summation of f of y, it is what? 150.2. 365. Divided by what? Divided by XC, summation of the components in XC, like this, right? So then we get our direction, which is an inverse of that method denominator. Use your scientific calculator. The resultant will be 9.87. .87. At x and y. So this is the angle. So because this is the angle, resultant force is this one. So because today we have an angle, we write our answer including the angle. So the questions was asking us to find out the resultant force. The resultant force at x is at 9.87 degree, and also the angle, can pull it out. Find the resultant force at x. So in our angle at x, first of all we introduce the force. So it should mean 200 at 4.54 Newton. So let me put the homework there so you can enjoy it. The quiz and homework. This is example 10. Homework. And this example, I have to refer the book that has been written by Tom Duncan. Don't remember the page and the question number, I saw this question. Find the resultant force at x and y. Resultant force at x and y. And y due to a given charge. At x and y due to a given charge at q and p. Y. This is Q. It's from Coulomb. This is 1 centimeter. This is 1 centimeter. This is -4 Coulomb. This is 8 Coulomb. This is the X. So Y, if Y, X, you have X, the distance from here to here, it is 1 centimeter. Distance from here to here, on line. So distance from those 2 points has been given that it is also 1 centimeter. So this is also equilateral area. Right? And you have to make sure that you write this is a conceptual question. Okay, so try it yourself. I've taught you the concept. So you have to find out the resultant force at X and Y with the given charge at Q and what and P. So where is P? First of all, even Q is not there, but G. Okay, so try, take the image or the solutions how we solved it. But remember that you have to find, read the question carefully. Find the resultant force. Find the resultant force at X and Y with a given charge at Q and P. So you have given charge this and this, so P and Q. Right? So, okay, do, and then we'll see what will be next. So we are going for example 11. Make sure that you do that example 10 and submit your homework on the comment section. Very interesting. So now electrostatic is getting smoothly and beautiful, right? With this kind of examples, because you see triangles, what we are dealing with quantity of charge. So example 11, let me put it on the blackboard there, because we are using a little bit different unit. And the question says that the figure below, okay, the figure below shows 2 charges. Shows 2 charges. Okay, shows 2 charges. Q1 is equal to -6 nanocoulomb. Then Q2 and Q2 is equal to 6 nanocoulomb. Okay, nanocoulomb, which are 12 centimeter apart. Which are 12 centimeter apart. Okay, apart. In vacuum. In vacuum. Find the force at B. Find the force at B. Find the force at B. This is B. Q2. Ha! Tell your neighbor that this is advanced physics. Charges are presented in figures. So you have not been wasting time when you'll be dealing with triangles, finding the area. This is negative Q2. They really enjoy it. This is 15 centimeter. Okay. This is 9 centimeter. Then here we have set 7 degree. Some of my students say, Jesus Christ. What does it mean? Things are getting tougher and tougher and tougher. And then they have been suppressed electrostatic. The one that I did during my Form 1, static electricity. Just to change at rest. Thunderstorms, lightning. These cases are not serious. So some of my students, they are saying like that, and I taught them physically. Then the distance between this one is 12 centimeters. That's all. Okay, you can pause the video and try to test yourself whether you understand this is tough or you're just going through. You should not worry if you find you notice yourself that you're going through. But this is very interesting part. Yeah. I'm laughing because I know what you are going or what we have to expect in this question and even in this question that you placed there. Because you are dealing with Y and dealing with what is X. So there you have to be very careful. And for this guy, we're dealing with Q2 and Q1. Q2 and Q1. This is what Q2 and this is Q1. Excuse me, don't worry. That is a good music to solve physics problem. Okay. So you have that problem. I would like to solve it quickly so that I may end this session. And I know that I have to prepare my students to be happy. The figure below shows two charges, Q1, negative 6 nanocoulomb, and dot Q2, positive 60 nanocoulomb, which are 12 centimeters apart. And then in vacuum, so they are placed in vacuum. Find the force at B. And B, the distance from B to Q1 is 9 centimeters. B to Q2, it is 15 centimeters. Solution, the first step. The first step, I know that this will be common for every student. Because what, even if you don't get the right answer to the question. Because the Coulomb, yes, write this one. You have even maybe half of the marks or 1 mark. Coulomb sorting, mathematical formula. Mathematical formula. Okay? This one, right concept. I will show you a concept that I haven't shown in the previous examples. Or we didn't touch it seriously. So you say the electrostatic force of attraction or repulsion is equal to proportionality constant times Q1 times Q2 of 40 square of the distance between them. So you find that now having the formula is not a problem for advanced level. The problem now, how you can use that formula to solve a given problem. Okay. So what do you say? So you say that we are dealing with this point B. Just to simplify life, let us start B, what the force of attraction. So first of all, for the second step, in order to deal with point B, we have to say that let quantity of charge at point B to be what? 1 microcoulomb. This we call the unity charge. Unity charge, 1 microcoulomb. So here is 1 microcoulomb. So it's the force of attraction between 1 microcoulombs and this negative 6 nanocoulomb. 1 nanocoulomb, not micro, excuse me. So half plate is equal to 1 Coulomb. This is capital C, please. So 1 nanocoulomb. Say 1 nanocoulomb. 1 nanocoulomb. 1 nanocoulomb. Okay? That's what you have to let. And should be positive, but negative, because you should stay the charge. Okay? Also, that is good music to solve a physics problem. You should not get lost because of that music. Okay, so next we go for the steady state. I want to finish this question powerful. The steady state, we say that let us compute the force of attraction, or the force of attraction that will be on point B due to Q2, due to Q1. Q1, right? So electrostatic force of attractions between B or Q at B or QB and Q1, this is equal to what? Proportionality constant, which is 9 exponent 9, and then you have the point of charge is 1 nanocoulomb. 1 nanocoulomb is equivalent to, or is equal to 1 exponent 9 coulomb, multiplied by what? Q1, which is 60 nanocoulomb. So 6 exponent negative 9 coulomb divided by what? The distance between them. It is 9 centimeters. So 9 exponent negative 2, you change it into meter. So this is force of B due to Q1. Use your scientific calculator, compute the response. For me, I did it. And I found that is 60.6 exponent negative 6 Newton. 6.6 exponent negative 6 Newton. Where will this force be directed? Upward, right? Upward. So it will be attracted. No, downward. So this will be attracted downward. Okay. So next we come to the first 2. Here 15 there. Then we begin. So we find okay. So, the FBQ1 is vertical component. So this vertical component, this is downward. So it will be attracted toward what? Q1. So this is only contains the vertical component, don't have horizontal component. When we come to this point now, that is the same, it's a force state now. If you didn't understand well mathematics during your O-level, then you will suffer some consequences there. What consequences are you going to suffer? This is the consequence you are going to suffer. If you didn't understand the concepts of geometry in mathematics from 1 and from 2, then there you suffer. Because the angle of angle is the concept of angle. This is 37 degrees. So listen, here you have Q at B. Here you have Q2, want to start it. So then, if you prolong, this is the horizontal line passing along Q2, right? So then here we formulated a ZE, this is the Z. So you say that this line is in parallel to this line. So if they are parallel, then here we have 37 degrees. But we know that the total degree from here to here it is 90, right? 90 minus 37 is equal to what? 53, is it? Yeah? 53. So this is 53 degree, right? And this is 90. So the issue of angle is very important. So now, the force of repulsion, because this Q2 is positive and Q at B is positive, the force of repulsion there will have both. Yes, that is good music. Okay? So, the force of repulsion, for this case, it will have both horizontal component and vertical component. Right? Why? Because this is diagonal. So the horizontal components will be in this direction, and the vertical components will be in this direction. Right? So you can have your right angle triangle. So simply, remember this length is parallel to this one. So okay, so this one means that we'll have something like this one. So what does it mean? It means that we are going to have horizontal components, and also a vertical component. So what will be our angle? So suppose that if you, maybe these notations is confusing you, we can just prolong another right angle triangle here. I think you believe it, right? So if you prolong this, so this will be partial, so this charge will be pushed away, right? So if that's the case, it means we have the vertical components and also horizontal components which will be pushing like this, right? So if you be pushing like this one, so this one, it will be a horizontal component of XB. So let's say a horizontal components of XC, B due to Q2. And this one will be FXY, B to Q2. Right? So if that's the case, we know that the angle will be set 7. That's why a big given an angle. So it means by using what? So for instance, for that case, so we say that this is the fifth stage. So the first stage, we say that you dissolve what? Dissolve the forces. Okay? So the fifth stage, listen careful. Listen careful. The fifth stage, we say that from what? From Pythagoras, no, from what? Yes, from trigonometry. From trigonometry concept, right? So we say that cosine of 37 degree. This is equal to, suppose that here we have, we call it a resultant force acting upon B due to Q2. Not the entire resultant force. The entire resultant force acting to this is due to Q2 and Q1. I'm not talking that. But this is provisional force. So this one will be what? So okay. So cosine is the adjacent of hypotenuse. So okay. So this will be the horizontal component of force of repulsion between QB and Q2. Right? And hence divided by what? Divided by resultant force. So resultant force between B and what? And Q2. So horizontal components now of the force BQ2, okay, which we used to call this one as sum of XC, right? Then this one, it will be equal to what? Resultant of X, so that resultant force, and then B what? BQ2 cosine of 40, cosine of 37. Alright? So that's one of the equations. So if that's the case, but we know that this is the sixth stage. The sixth stage, we say that this resultant force, BQ2 is equal to what? BQ2, this is equal to K, then you have what? Q at B times Q2 over R squared. Right? Okay? So suppose that this is equation 1 and this is equation 2. Physics is beautiful. I'm about to end this session. You have to enjoy and listen carefully to this question because it will help you. So now we say that the force of X is due to Q1, not due to Q2B. This is equal to what? K, and K is what? 9 exponent. First of all, to make that 6 step, we have that one, okay? So 9 exponent 9, and then times what? 6 nanocoulomb. So power negative 9 times 1 nanocoulomb, okay? Divided by distance between them, which is 15 exponent 30 negative what? Negative 2 square. But here we have what? Cosine of 37. Right? Because this is the resultant for that case. So we have the electrostatic force of horizontal component Q2B is equal to that. So use your scientific calculator. You have to find the computation, and finally you'll find is 1.92 negative 60 Newton. Okay? So that is the horizontal component. And the good thing, because when you analyze, you have only one horizontal component. So this one will also write as FFX, summations of horizontal component, right? So you go for the seventh step. The seventh step, by using also trigonometrical, we say that the force of horizontal component due to the charge at Q and then at B, Q2, this is equal to what? It will be equal to the resultant force and then of B due to Q2, and then we say what? Sine of 40 of the angle, which is 7. Right? Have you understood? This is just like a right angle triangle. You know this one. You are looking for this side and you are looking for this side. Okay, you understand? So if that's the case, this value, the value of this one is what you have there. Right? So the only thing, you just change the trigonometrical function. Q2 is equal to what? 9, exponent 9, then times what? 60, exponent negative 9, then times what? 1 from negative 9. And then we divide by what? 15, exponent negative 2 squared. And this one, your sine of 37 degrees. Use your scientific calculator, you will find that the vertical component of force of repulsion between Q at T, between a pointed charge at B and at Q2. If you do your computations excellently, you're gonna find that it is 6.667 exponent negative 6. Yes, so they'll be closely, or they'll be, this isn't, wait, Fy, we have one of the component which is 1.44. Where do you get this 1.44? If 1 is negative 1.44, so negative 6, isn't it? Yes, it's negative 1, negative 1.20, or 1.44, so negative 6. 1.44 actually negative 6 Newton. Right? Good. Are we together? Okay. So then we have our horizontal component. The eighth step. The eighth what? Eighth step. We have now to compute what? To compute summations of vertical component of force, F1. How do we find it? First of all, we have to know where the directions of this vertical component is upward. Say upward. So upward. So this is upward. So it's pushing it upward. This one is pushing it upward, while this one is attracting downward. So these forces are in opposite direction. To get the resultant vertical component's force, we have to subtract. Right? Right? Okay. In case you have any question, don't hesitate to ask in the comment section. And now you have to tell your neighbor that now I'm solving problems of electrostatic. Before I was just touching, was just like clicking. But now they're really solving because we need to employ the mathematical concept. So you say that to find the vertical component for this case, this will gonna take what? So we say that first of all, before just we find that numerically, we have just to say that this is the point E. You see that this is the charge. This charge at point B. Here you have what? Q1, another charge. So this one is pulling it down. And here we have what? Q1. This one is pushing it up. So if we resolve the force, you find that it's pushing it up. So what happens? So it means that Q at B, so Q, the point of charge, 1 nanocoulombs at B, this one will be pushed up by what? By Q1. Is it? No, it will be attracted down. So this will be attracted down by Q1, and then it will be pushed up by what? Q2. Okay? So the resultant vertical component of force, F of y, will be equal to what? The maximum to 60.67, 6.67, equal to negative 6, Newton minus 1.444 exponent negative 60 Newton. Do such subtraction. Because I know some students are still copying. So summation of vertical component, this is equal to what? Use your scientific calculator. The answer is 5.22. 5.22 exponent negative 6 Newton. Then we have to remember the principle. How can you find the resultant force? That will be, which is step? The ninth step. The ninth step says that computing resultant force. Compute resultant force. What do you say that? Resultant force. So you say that the resultant force is equal to square root of what? Summations of horizontal component square plus summation of vertical component square. Okay? So then I can clean the remaining part. If you didn't finish to copy, you will watch the video. Okay, you play back. So then, so you say that the resultant force for this case is equal to the square root of what? We have 5.22 exponent negative 6 square plus what's the horizontal component? The horizontal component is 1.92 to negative 6. My students here just pray for me to end the session. Square. So the resultant force is equal to what?
5.56 exponent negative 6.
Yes, 5.56 exponent negative 60 Newton, not members, but the resultant force. So it's not enough to find the resultant force. You have to think also about the angle. So step number 10, 10 step, find the angle. Right? Find the angle. So the angle, we say that this theta is equal to tan inverse of what? Summations of vertical component over summations of horizontal component. Right? So this is equal to what? Tan inverse of what? 5.222 exponent negative 6 divided by 1.92 exponent negative 6. So then, what the angle?
69.8.
69.8 degree, not mangoes.
Yeah.
Or oranges. 69.84 degree or 8. So then you conclude. Should I leave another homework? Students are saying no, sir. We'll make a battle with you. So therefore, the resultant force is what? 5.56 exponent negative what? 6 Newton. Okay? At the direction of 69.8 or 70 degree. So, if I say that we just solve the 2 questions in one homework, then so you can see how the battle it is. What if we solve maybe 7 questions in one session? I think that we rush and we'll be running. We don't want you to run. So get prepared. We have another session, which will be session 8. We'll be solving again problems on these concepts of electrostatic. So I thank God who have been with me during the preparation of these sessions and even when I've been teaching. And I thank God also who have given you a chance to be with me in this session. May God bless you abundantly, and I would like to ask you to join me in session 8, where I will be having problem solving in a fundamental law, Coulomb's law, and the we call it the superposition principle. Right? Make sure to go through and you watch these videos and you learn them sequentially. Don't jump, because if you jump, you'll be missing some concept. Then remember that to subscribe, press the buttons of subscriptions there. Then remember also to comments, to ask your questions in the comment section. And also remember that in case you feel from your heart to offer your thanksgiving, you can send it through this phone number 0759745331. We don't need we call it assist. We don't need just like what we call it, how do we call it? You don't need something called okay. You can donate. Just donate as an offer. Don't donate as just like we have a problem, so we are looking for financial support. No, God is faithful. We're gonna pay with this for this program. So, but we call it Thanksgiving because you pay it. It means you offer it what you feel from your heart. No any limitations. Whether it is 500, whether it's any amount that you feel from your heart that will make a radical change for the present and future generation. Again, once again, that one thing that if you have any questions, don't hesitate yourself to ask in the comment section. I'll be praying for you, pray for me. Make sure to go through these sessions and you enjoy them. And also think that how you can take these classroom instructions to solve real life problems, because that will be the next phase. The next phase, so after this mathematics and the science programs, I will have engineering programs and the computer programming. So when that, I will show you how do we take the classroom instructions and solve engineering problems because we have in our community. So may God bless you. See you in the next sessions. Okay, and I'm very happy to be a part of your life success. Be blessed. See you then.